Hey, what's up, guys? We're going to look at deriving the equations of motion. So what are the equations of motion? They're four equations that describe constant linear motion, which means motion with a constant acceleration. There's five letters. S stands for displacement, U stands for initial velocity, V stands for final velocity, A is the constant acceleration, and T always stands for time. And our four equations of motion are V equals U plus AT, S equals UT plus half AT squared, S is equal to U plus V divided by 2 multiplied by T, and V squared equals U squared plus 2AS. You need to know how to use these equations to solve problems, but you also need to know how to derive them, which means actually find out how we can get these equations from first principles. So the first one, V is equal to U plus AT. And we're going to start off all of these derivations using the same graph. This is a graph showing constant or linear motion. It's motion with a constant acceleration. We've got an object that starts at a speed u, it ends at a speed v, and it accelerates over a time t. We know the acceleration is constant because it's a straight line graph with a constant gradient. And we need to derive this first equation, v is equal to u plus at. And what we're going to use for this first equation is the fact that if we've got a velocity time graph, the acceleration is equal to the gradient, which is equal to the change in velocity divided by the change in time. So I'm just going to draw a couple of things on here. We always start off by drawing triangles whenever we do gradients, or at least I do, because it means I don't get things wrong. And I can see that the change in velocity, delta v, is given by v minus u, and the time it takes is t. So the acceleration is equal to change in velocity divided by time. So a is equal to v minus u divided by t. Now it's just a little bit of simple algebra. I'm going to multiply both sides by t, which gives me at is equal to v minus u. And now I want to add u to both sides, which takes the u to the other side, which leaves me with v is equal to u plus at. And there we have it, our first equation of motion, just by using the fact that the acceleration is equal to the gradient. We're now going to derive the second equation of motion. S is equal to ut plus half at squared. We're still going to use this same graph showing linear motion, but this time, rather than using the gradient, we're going to use the fact that the displacement on a velocity time graph is equal to the area under this graph. So on this graph, you need to, when you're doing this in the exam, you need to separate this graph into two portions. And I'm going to call them area 1, which is a rectangle, and area 2, which is a triangle. So the displacement is equal to area 1 plus area 2. So let's look at each of these areas in turn. Area 1 is a rectangle, which means that its area is length times width. So the length is t, t, multiplied by u, which gives me area 1 is equal to ut. Area 2 is a triangle, so you should know that the area of a triangle is half, multiplied by the base, multiplied by the height. We can see that the base is t, and the height is v minus u. So we can put a2 is equal to half, multiplied by t, multiplied by brackets v minus u. And we're almost there. We just now need to use equation 1. V is equal to u plus at. I can rearrange that to give me v minus u is equal to at by taking away u from both sides. And now I can substitute at in place of v minus u, which gives me a2 is equal to half, multiplied by t, multiplied by at. And if I simplify that, that gives me half at squared. Now we just add these two areas together. The total displacement is equal to area 1 plus area 2, which gives me ut plus half at squared. And there we have it, the second equation of motion derived. The third equation of motion is incredibly easy. And we're not really even going to use a feature of the graph, we're just going to use a bit of common sense. That the displacement is equal to the average velocity multiplied by time. The average velocity is simply u plus v, so it starts at u and it ends at v, and we divide it by 2. Therefore, the displacement is simply u plus v over 2 multiplied by t. And there's our third equation of motion, really easy to derive. The fourth one, we're actually just going to use two previous equations to derive it from. So we're going to use equation 1, which is V is equal to U plus AT. And we're going to use equation 3, S is equal to U plus V divided by 2 multiplied by T. And we're going to use these and rearrange these two equations to get V squared is equal to U squared plus 2AS. The first step is to rearrange equation 1 to get T by itself. So I can rearrange this to give me T is equal to V minus U divided by A. And now I'm going to substitute that into this T here, into equation 3. And that leaves me with S is equal to U plus V divided by 2 multiplied by V minus U over A. I'm going to multiply both sides by 2A to get rid of the 2A at the bottom. And that gives me 2AS is equal to brackets U plus V brackets V minus U. Now all that's left to do is to expand these brackets out to multiply them out. So get 2AS is equal to UV minus U squared plus V squared minus UV. The plus UV and the minus UV cancel each other out. So we get 2AS is equal to minus U squared plus V squared. And that, if I just want to get rid of this minus U squared here, I can take it over to the other side and I get V squared is equal to U squared plus 2AS. And there's our fourth equation of motion. So this page just summarizes everything that you need to know. You've got 4 equations of motion to derive, and you can get them all from this one velocity time graph. For the first one, V equals U plus AT, you must use that the acceleration is equal to the gradient. For the second equation, you use the fact that the displacement is equal to the area, and you separate the graph into area 1 and area 2. For the third equation of motion, use the fact that the displacement is average velocity multiplied by time. And for the fourth equation of motion, V squared equals U squared plus 2AS, you've simply got to use equations 1 and 3 and do a tiny little bit of algebra. That's it. Thanks for listening. See you all soon.